I'll be talking about Jamovi again, yet again, and there'll be more in the future, I'm sure. I really do like it, and most students actually do like it because it is available at no cost to everybody. Um, it's easy to access, and it's a great learning tool. Um, it has excellent graphics, and you can actually publish stuff with it. It's acceptable as a software if you want to publish anything ever. It's free, it's there, you can do your thing. It is easy to enter data, it is easy to edit data, it is easy to import data. If you already have like an Excel spreadsheet, you can just put it in and it works really nicely. So it's a good thing. It's a good thing to have, right? Something that 20, 30 years ago we could only have dreamt of. It's like, no. Okay, just a quick little discussion about probability and what it is. It's just we have to have an experiment and an event. Okay, if you don't know exactly what that is, you don't need to worry about it. You'll see in an example what I mean. So what is probability? It's just a measure of likelihood that something will happen, right? It does not predict with 100% that something will or will not happen. Okay, that's something important to keep in mind. Okay? And we have to know what the experiment is so that we can calculate probabilities correctly. Okay, you'll see what I mean in an example here, right? Simplest formula here is just, if you can count, and I'll do examples where you can actually count, which is good. It's just the number of outcomes in A, the event A, and then divide that by the number of outcomes in the whole under consideration, right? So everything that you would have, all possible outcomes, right? You have to know how many outcomes I can have to begin with. Okay. If you cannot count, then you have to use calculus, so it gets a little bit involved. But yeah, it's good though. So we'll leave that for some other time. So I want to focus on conditional probability in general because it's very often it's a pretty challenging topic for most students when they first see it. And in fact, it's not really a difficult concept when you actually understand what you need to do. The problem is in each experiment, you may have to do different things. Okay, that may be an issue sometimes. So we have to have two events, right? So the probability that B will occur given that something else has already occurred, I call it event A, is called the conditional probability. And this is how it is defined. Notation is just B with a vertical slash A. So you have to somehow know how to get the probability of A and B, right? That's the intersection that I talked about. Was it last semester? I don't remember. A and B, right? And then you divide that by the probability of A. So the probability of A better not be 0, right? You don't want to condition something by an impossible event. Make sense? Ooh, yeah, don't wanna do that. Yeah, don't want to have 0 in the denominator. Okay, so yeah, exactly, right. And preferably, yeah, you want A and B to have something in common. Right? You'll see what I mean in a few minutes here. Are we doing okay so far? Okay. First example, right? So I'm describing an experiment so that we know exactly what we're going to do. Okay. So I'm going to draw one card at random from the standard well-shuffled deck of cards. No jokers in it, right? So we have 52 cards, is that right?
Yeah.
13 in each suit, right?
Yeah.
Oh, okay. How am I going to calculate probability of getting a queen given that I draw a diamond? Basically, I'm asking, right, what percentage of diamonds are queens? Right? That's what I'm asking, right? So numerator, right? I have to know, well, the card has to be a queen and a diamond at the same time. There's only one such card, right? We're not playing any tricks here with weird decks, right? So that'll be 1 out of 52. And then how many diamonds total? 13, right? So its probability is 13 out of 52, right? Now, if we know a little bit about algebra, right, I don't really need that 52 in there, right, because that's gonna cancel, right? It's good to write it once you're learning that concept so that you know, oh, okay, yeah, that 52 is there. It's just, in the end, it won't really matter, right, because when you cross multiply, that 52 will go away. Or you can just keep it that way, the way it is. I mean, it doesn't matter. So yeah, there it is, right? 0.077, right? And you are done, right? So in other words, 7.7% of all diamonds are queens, right? That's it. That's what conditional probability is all about, really, right? Understanding that simple concept, right? What if I switch the order, right? Well, things are going to be a little bit different, right? The numerator will be still the same because I still need queen and a diamond, right? That one card in the numerator. However, because now I'm conditioning by queens, right? That will be only. This thing now is not working. There are only 4 cards, right? 4 queens out of the whole deck, right? So the number, right? The end result will be very different, right? And this is where a lot of students have difficulty, right? Switching the conditionality around. Okay. It's really not the same question, right? So the answer cannot be the same. It could happen sometimes. In certain experiments, it can happen, but it's rare. Most likely, it's not going to be the same number. Okay, how are we doing? Doing all right? So 20. What I just showed is that 25% of all queens are diamonds. Yeah, because there's only 1 out of 4, right? So that's it. Note that we assume that probability of A here is not 0, so I'm going to multiply both sides of that equation by P of A. And this is what I'm going to get. And this is an interesting and useful formula, right? When I need to find out probability of A and B. Sometimes I don't have to use that formula. We'll see in my example in Jamovi, I don't have to use this particular formula because the data is already set up nicely that I don't have to do this. But however, in some experiments, you do want to do this, and here it is. Here's an example, right? Here is another experiment. I'm going to draw 2 cards at random from our standard well-shuffled deck of cards. What is the probability of drawing 2 aces? So I have to be very specific here, right? If the first card is not replaced. So we have to be very detailed when we describe these experiments so that we can calculate these probabilities exactly, without any doubts or whatever. Nothing ambiguous, right? So I'm going to use A sub 1 and A sub 2 to represent these 2 events. I'm talking about 2 events. Okay. A sub 1 means an ace on the first draw, and then A sub 2 will mean an ace on the second draw. Okay. So here it is, right? And this is where this conditionality, right, comes into place, right? So yeah, it's a multiplication rule. First, right, what is the probability of getting the first ace? There are only 4 out of 52 cards, right? However, on the second draw, right, this is where the conditional probability comes in, right? We are left with 3 aces and 51 cards, right? Because the first card was not placed, right? So the probability is really, really small, right? Don't bet your savings on things like that. Chances are you're going to lose. It's very unlikely, right? It's not an impossible event. It just tells you that it's very unlikely, right? That's all the probability does. It doesn't tell you what's going to happen or not. I mean, it's just, this is highly unlikely, so be careful with them if you want to, gamble or something like that. Don't. Probably, you'll be better off. I mean, you may be lucky, but who knows, right? I didn't say that. Okay, so now we're going to see how these conditional probabilities come into an applied setting, right? So we are going to create a very special kind of table from which we can read and calculate different probabilities, right? Okay. So I'm going to open here. Jamovi's already open, so I'm to switch to that screen in a minute. We're going to go into analysis and frequencies and a very special type of test that we're going to do. And we're going to see how to create this very, very nice table, right? Right, so what's going on here? So we are looking at 63 people total, right? They were either vaccinated against the flu or not, but everybody was exposed to the flu virus. So everybody experienced either mild, medium, or severe symptoms. Okay. Are we okay so far? So we understand what happened here. Okay. So N under vaccinated, N means what? Whoops. N means yeah, you were not vaccinated. Right? Okay. And Y means yes, you actually did take a shot for the flu. Okay. And then we're going to create this. This is very nice. You see this in research quite a bit. These are very good because these give you conditional probabilities and probabilities of the intersection of each intersection. These are really nice to read. But you have to know how to read it, so we're going to see how to do that in a minute. Are we okay so far? Okay, now I have to switch to, I gotta end the show, okay, for a minute here, and here we are, right? Okay, so, and usually this is how your data set looks like. Okay, so each case will have its values. These are either string values, and these are categorical variables. So there are no numbers here, okay? When we say data, we don't necessarily mean numbers, okay? It could be symbols, it could be letters, it could be paragraphs, it could be essays. That's all data. Okay. If you ever want to do survey analysis, you're gonna see that kind of stuff. It gets really bizarre. It can get bizarre, but anyway. Okay, so let's get that contingency table. So I'm going to go into frequency, and I'm going to do a chi-square independent test. You don't need to know what that chi-square independent. If you don't know what it is, you don't have to know it. Now we have to decide. We really have a choice. You can put the variables vaccinated and flu symptoms in either rows or columns. Right? You usually choose. I chose to put vaccinated into rows and flu symptoms into columns. Okay. Come on. Yeah, anyway. Okay. And there is that table, right? There is that table that we talked about a few minutes ago. Okay. Now I need to create a bunch of probabilities, right? So I'm going to open here this menu under cells. Observed counts, we want to leave it because these are the observed counts. That's what they mean by observed counts. I'm not going to worry about expected counts. One day when I talk about chi-square test of independence, I will talk about that. But anyway, let's leave that for some later date. But we do need percentages for row, column, and top. So we're going to select that. Pretty easy to do that. And if I can minimize this thing, that would be nice. But anyway, here it is. Here's that table that I had in the slideshow. I cannot move this thing. I usually can, not in this. Not on this computer. That's interesting. Okay, so let's get back to the. Let's get back to the show here. Let's get busy calculating stuff. Okay. Okay, so we created this, we created that, right? So everybody's okay so far? Yeah. So it's pretty easy to get that, right? And believe it or not, you have a lot of information here going on. Okay. So first question. Okay, determine probability of n given medium, right? And interpret the result. So basically, we want to see what percentage of those who experienced what medium symptoms, right, were not vaccinated. So you have to, this is where our students make a lot of mistakes. You have to kind of read from right to left. Okay, yeah, because that's the notation we accepted, many decades ago. So that's how that's read, right? Okay, so how are we going to do this? Okay, so we can calculate. Let's see. All right. So it will be what? What do I need in the numerator? I need to have what? N, right? Not vaccinated and medium, right? That's 15. 15 over 63, which, as we said, I don't need that number, but I'll just write it there, right? And then we need the total for medium, right? How many people experience medium? 25. So it's basically 15 over 25, or 60%, right? And where is that 60%? Well, you see it in the table, right? Where is it? I lost it here in a minute. Right here, right? Right here, right? It's percentage within column, right? Why within column? Because we are conditioning by one of the column events. Does that make sense? All right. So it's right here, right? Jamovi already calculated that for us. It's right there. Right? I'm just showing you, illustrating you the formula yet again, right? Because it's kind of nice to get that formula down, right? And that's 60%. Doing okay so far? Therefore, 60% of those who experienced medium-level symptoms were not vaccinated. Okay. Similarly, right, what if I switch? Things will be different, right? Don't expect the same answer. Usually it's not the same answer, right? I can just read that from here, right? Because now we are conditioning by N, which is a row category, right? So it's going to be what? 45.45%. Yeah, it's what? It's just 15 divided by what? 33, right? The total in that row, right? Because I'm conditioning by N. Well, I went too far. Oops. What did I do? Okay. Are we? Yeah, we are right here. So 45.45%, right? Of those who were not vaccinated, right, experienced, what did we say, medium-level symptoms, right? You're okay so far? Yeah, so these are the kind of things that researchers really want to look into, these things before they analyze, if how one variable affects the other and that kind of stuff. Right? Whether it's sociology, social work, biology, you name it, right? They all use this kind of stuff. And notice, yeah, we are counting outcomes because you can count how many people were in each category, right? Okay. Similarly, right, what percentage of those who were vaccinated experienced severe, right, symptoms, right? So you would calculate in the same way, right? Now it's going to be what, 3? So we have to look at what severe given y, right? Okay, so it's going to be what, 3 out of 30, right? 3 out of 30, which is 10%, right? So 10% of those who were vaccinated, right, experienced severe, right, flu symptoms, right? Okay. So our natural question here would be, as a researcher, right? Well, was this particular vaccine that you're effective, right? Based on a very small sample, right? Usually we have much larger samples to base this kind of data, and people do track that, right? So this is very important, right? When a new vaccine is developed every year, right? This is the things they also look at, right? But anyway, similarly, if we switch the order, right? We're going to get 1875, right? So 18.75% of those who experienced severe symptoms were vaccinated. Okay. Determinant P of mild given y and interpret, right? And this is what sometimes some of my students will do. So what happened? Why is this not correct, right? I'm asking, whenever I ask in class, right, is this correct? Probability is about 90% that the answer is no. Given in probabilistic terms, right? Is the numerator correct?
Yeah.
Because we need what? Mild and y, right? We are mild and y, 17. And then student divided that by 22. No, because 22 is the total for the mild, right? And we're not conditioning by mild. We're conditioning by y, by yes, under vaccinated, right? So we need to divide that by what? 30. Yeah, there you go, right? It could be confusing in the beginning, right? That's fine, right? That's why we need practice, right? So the correct answer is 56.67, and therefore 56.67% of those who were vaccinated experienced mild symptoms. All right. 5 minutes left. Now, here's an example of a probability where you have to do a little bit of calculations on your own, because Jamovi cannot do this quite easily unless you program it to do, right? But let's not do that. So the question is, what percentage of those who did not experience mild symptoms were not vaccinated? Right. So what is the event that we are conditioning by? Not mild, right? Right. So if you are in the mild category, whoops, I don't want to show that yet. If you're in the mild category, okay, where are we? Okay, here. All these people will not be considered, right? Because we're conditioning by not mild. Let's write that here, right? So what percentage of those who did not were not vaccinated? So it has to be, if I understand, B O N given not mild, right? Okay. Ooh, fancy, right? The complement, right? Remember complements? I talked about it last fall. Okay, maybe not. Not mild, right? So anybody and everybody in the mild category will be out of consideration. Okay, tell me, how would you calculate, given that you see those numbers? This is a quiz now, right? Well, you can start with the denominator, right? How many people did not have mild symptoms?
Medium.
Okay, so you're either medium or
Severe.
or severe, right? So what's the total then? Ah, 16. Right, or you could have done what? 63 minus what? Is that going to work as well? Yeah. Should be the same number, right? Because we said we have to exclude the mild symptoms, right? Okay. What's in the numerator? Where are we? We are in the category N. So it's going to be what? 15 plus 13. There you go. You're done. Right. Yeah, so Jamovi cannot really do this automatically for you unless you kind of program it, but it's easier, in fact, to just do these kind of things by hand if you want to know that kind of stuff. There it is, right? So it's going to be 15 plus 13 over 25 plus 16, and that's what? 28 out of 41, 68.29%. Your probabilities have to be less than 1 or less than 100%, right? That's a good check. Sometimes my students don't check that. They get 3.7, which is 370%. Yeah. Ain't gonna work unless these kind of numbers occur when we compare to probabilities in a different way. But anyway, that's not going to happen here. We have 68.29%, right? So there we go. 68.29% of those who experienced medium or severe Now I'm using that complementation rule, right? Because the complement of mild is what? Medium or not and, or union, right? Severe, right? So 68.29% of those who experienced medium or severe symptoms were not vaccinated. So I can combine these categories in any way I want if that's what I'm interested in. Right? I can always use that contingency table to get those numbers. So yeah, no, that not mild, right? The complement of mild is just the union, right? It's the union, right, of the other two categories, right? Medium and severe. So we are right on time. 12:45. Perfect timing.
Nice.
I could go on, but yeah. I won't.